Okay, cool. So this is my session on building Robo-Army. I use Angular and NativeScript, and there will be like two types of applications that I will be building. My name is Sebastian Witalec. Yeah, I do a lot of Angular, that's why I say that, and I like to play with robots and all sort of weird stuff. If you're on Twitter, you can follow me. I'm Seba Wita. Like, I don't tweet all that much. I like to drop funny things or interesting things every now and then. And as of last week, I decided to go for 10,000 followers. I'm on 3,000, so it's going to be ambitious to do it in 12 months. Anyway, I want to tell you a little story. And you will be a little bit surprised at first. You'll be like, what the hell is he talking about? But it is important to understand the whole concept and why I do what I do. So we all pretty much can agree that squirrels are pretty cute, right? You know, like they run around, eat their nuts, and etc. Like you can go and pet them. If you're in London or Boston, they're quite friendly there. But the question is like, are they really? You know, because where I live, like there's like this little park, like 10 minutes from here, where the squirrels kind of became a little bit vicious. So this is Jack, and like something went into his head, and he started throwing peanuts at people with allergies. And so people with allergies was like, whoa, I can't go to that park. But this was just the beginning. Like some of the squirrels started looking at it, and it was like, okay, so Jack is doing something crazy. There's more space for us. Nobody's chasing us with dogs. Let's get rid of the people. So they started arming themselves. You know, they came with bazookas, machine guns, and all of that, and they were like literally taking over the park. And I was like, wow, this is messed up. We have to call for some help, right? So we called in the stormtroopers. You know, the stormtroopers come in, are like, that's it. No more peanuts, no more guns. You guys have to calm down. So like, you know, basically the stormtroopers subdued the rebellion, and it was like, okay, this is over. You guys have to behave. And we all pretty much know, like, you know, if you point a gun at a crazy squirrel, the squirrel is gonna behave, right? Well, no. Well, the squirrels were a lot more cunning than we all expected. And then even find out how to actually fight back against the stormtroopers. So at this point, we were like, damn, this is going really badly. We have to do something about it, right? Like the stormtroopers were too scared of fighting the squirrels. So we made a call for help, right? And who answered? Well, the robots answered. They came back and they said, well, we don't really have lives or souls or anything, so if you get killed, we don't mind. So we can come and help you fight the squirrels, right? Like just give us some batteries or charge us and we'll be happy to comply. And we were like, yes, we have another army, let's do something about it. But there was a problem. The problem was of communication, because as much as all of us speak various languages, the robots speak, the robot language. You have to pass them some code, and then they will respond to you, right? So I was like, okay, so we have those volunteers willing to fight for us, but we have to learn the language and how to communicate with them. And this is where Bluetooth comes in, right? Like a lot of those guys expect you to communicate with them via Bluetooth. So we said, okay, let's figure out how this all works. So the first thing, all of the functionality in these kind of devices and robots is divided into a bunch of services. And then all those services will have like different services, like for dashboard, for weapons, for drive control, for different things, okay? And then those services then will be divided into a bunch of characteristics. So a characteristic would be like a speed indicator and a fuel indicator on the dashboard. Or for weapons, you could have a Q-tray and a laser, right? And then finally, drive control might have like a steering wheel, accelerator, and brake. So really, you talk to those characteristics to either extract information on like battery level or how much ammunition they have, or to tell it like, go forward, left, or right. It's just like you would have in a car, like, you have brakes and accelerator, steering wheel, all of that. It's pretty much the same idea. So once we have those services and characteristics, and see each of those will have like their special UUID. So that's like the code which we use to actually talk to a specific one. And it's either 4 characters for short, or some of them are 16 characters long. But it's always either 4 or 16, pretty much. So, and also like those services are usually write, read, or kind of mix, but usually they will be perfectly just write or just read, right? Like very often. Okay, so if we want to send a command, very often we have to construct each kind of like request that we're sending to the device by providing the service ID, the characteristic ID, and some sort of instruction. And usually that instruction, especially for characteristic, will say which of the items in that characteristic we want to use and what do we want to do, kind of thing. And this is also like one of the hardest things to figure out when you're trying to work with like a new device or new robot, is actually what are those codes are, what is the API that the robot expects. It can be sometimes quite tricky. So, and we can pretty much connect to Bluetooth like on both like web and mobile, and it all works pretty nicely. So we are going to have a look first at web Bluetooth. You know, like it's well supported in Chrome and pretty much a lot of modern browsers. And this is kind of like how it all works in 5 easy steps. And don't worry, I'm just going to go now step by step through that. But first, we have to install typings for web Bluetooth to our project. So you run npm install, save types web Bluetooth. And then later on, this reference types here, it's useful so that we can actually use the web Bluetooth types if you're using TypeScript, that automatically will recognize it for us. It's something I forgot yesterday, and I was reworking my demo, and I was like fighting with types for like a couple of hours, and then I found this line. I was like, oh, that solves it. Anyway, how we communicate with robots in web Bluetooth. So the first thing that we have to do is just use navigator.bluetooth and call request device. And we provide various filters. So we can provide filters like, oh, I'm looking for devices where name starts with word mambo. And also, I'm expecting that device to have some specific services available. So let's say if you're in a room that there's like 1,000 different Bluetooth devices, this allows us to filter out what device we can connect to. And just this little call will create a little pop-up in your browser that will start searching in like a little model window. And then every device that fulfills this criteria will be listed over there. And the moment you select one of them and press pair, this promise will return. So it will return like a device object that we'll be able to communicate with, which is pretty cool. The next step is how we basically issue a call. So usually we start by calling connect on the device, which gives us a server object. And then using the server object, we can call get primary service, and then we provide that UID for the service. So we can say like we want the dashboard service or the control service. You do that, and that gives you a service object. And then having a service object, we can then call get characteristic, also by providing the UID of that characteristic. And all of those, you can see those are promises. I'm using a single wait here. And then finally, when I have characteristic, we can issue an individual call to that specific characteristic. So this is done as follows. So basically what you can do, did I miss something? Oh yeah, this is, okay, so using the characteristic first, if you want to read a value, so like if this is a dashboard, you basically say characteristic.read value, and that will give you like a buffer type object. And then you can parse the value by just calling getUint8, and you say which of the bytes you want to convert. So sometimes if, let's say, you have a dashboard, you know, the first value could be for battery level, for fuel, for speed, for different type of things. So usually you kind of have to check the API or figure it yourself what each of those values really mean. But by just doing these 2 lines of code, you can extract values from a device. And then if you want to write send instructions into the robot or drone, you basically have to construct this int8 array by passing the values that you want to pass in. And then you basically just take the characteristic and say write value and then pass in that int8 array. And that's pretty much it. That's really that simple. So actually, the actual communication with the devices and drones is super easy. The hardest thing is to actually figure out the API or finding the right resources. So the first volunteers arrived to our army, and it wasn't actually super easy at first for me to work with those. Like, I literally took 3 days to make the drone take off, because there's like a lot of little tricks that it turned out that I had to do before making it happen. But I was very specific to this drone. But to make your life easier, if you do get hold of one of those guys, I created a library that is like, it's called Mambo Angular Service, that you can install in your project. And by just calling like mambo service.search and then drone.takeoff, the API will do everything for you. So that's pretty cool. So it's time to send the drone to scout the enemy. So I'm going to show you a bit of code of how I build this project. Hopefully you'll find that interesting. So in my application, basically what I do, I use dependency injection to bring in my Mambo service that I created, and then I call search, which gives me the drone object, and then like I have this observable that lets me know whenever we got disconnected, but then like I can call things like takeoff, land, etc., etc. But the more important thing is really the implementation that's underneath. So just the connection to the device, you can see I'm calling request device, getting device is called Mambo. The service UID, I can probably go there. You see, it's like I'm expecting them to have service with this UID and this one, which is like a whole bunch of characters. And then when it's connected, I'm kind of creating this drone object. So for example, the actual connection, again, is I'm grabbing this device and then call it connect. And when that's done, I can go and then do the initialization. So for example, I basically just go and say, hey, go get me this primary service, another primary service, get me a whole bunch of different characteristics. And then I save them into objects that I call like a flight command instruction or a flight status, etc., etc. And then finally, from the drone, I'll just show you one of them, takeoff. Basically, instructions look like that. So in order to send an instruction to takeoff, I have to send this code 010, and that's how you tell the drone to take off. If I send code 030, the drone will land. In order to, for example, make the drone change its flight parameters, you see this command is a lot longer. So I'm sending 0201, and then the roll parameter, pitch, yaw, and altitude, and then a whole bunch of zeros. And this, for example, command has to be sent to the drone like every 100 milliseconds. So you're constantly telling the drone what sort of things you should be doing, and the drone will kind of like carry on executing this instruction. And if those don't change, then and you were telling drone to turn and you stop sending instructions, the drone will just keep turning in a way. There's one other thing though. Whenever I send instructions, the drone also expects, before I pass in like this 010 for it to take off or land, I have to send this instruction to step 2. And basically step is incrementally, I kind of say this is instruction number 1, 2, 3, 4, 5, 6. So if for some reason the one instruction will arrive, let's say if I do takeoff and land very quickly, and if somehow land arrives before takeoff, the drone will know to disregard like the older instruction because of that step thing. But basically that's most of the idea. So if I run quick ngserve, I always forget that. Let's build this application and try to fly the little guy. Don't worry if you don't see him, he'll come to the view very soon. I built the wrong project. Anytime now. Okay, so when I press the search button, that's basically where I execute the search. You see, like, it responded really quickly. It found my drone. I can press pair, and that basically connects to the drone. And when it's ready to fly, I can start sending some instructions. So I can make it fly, go up. It also works like a pretty nice air conditioning. So like anyone is hot, like there you go. I can make it very close and friendly. And here we are. Years of gaming trained me for this moment. Hey, buddy. Pretty cool, huh? What do you think? Would you like to get one? Sorry, I'll make him land, and I might maybe hear. Yeah?
How did you solve fealty controller problems?
Oh, so the stabilization is completely built in. It's really, like, this little drone is really impressive. Like, I think I paid like £100 for it. And it has all the stabilization built in. I even fly him, like, in that park I was talking about. I fly him like in the wind and everything, and I fly him over trees and everything is perfectly fine. It's a pretty nice machine. All I have to tell it is like whether it's turning, going forward, or like, you know, whether it should be pitching left and right, etc. And the drone does the rest for me. So that's the really cool part. So yeah, what do you think? Pretty cool stuff, huh? You all want to have one now, don't worry. Cool, coming back to the presentation. I'll disconnect him for a second to save the battery. The battery lasts for about like 8-10 minutes, so it's not a lot. That's why I have like 5 of them. What's going on? There we are. So that was us building something for building a web application, running the whole connection from Chrome. But how about going outside of Chrome? Like, how about going for mobile devices? So what you can do, you could use NativeScript and Angular. It doesn't actually have to be used with Angular, but I really love playing with Angular, so I usually do that. And for those of you that don't know what's NativeScript, it's basically this open source framework that allows you to build mobile apps. And you can use use Angular, Vue, or pure JavaScript or TypeScript, and you get an application that has 100% native UI, which is really, really cool. And you get 100% access to all the native APIs that exist directly on the machine. That's how we could actually build the Bluetooth connection with the device, because the API for Android, iOS is open. And then, so one of our community guys, he actually created a Bluetooth plugin that allows you to do that. So let me take it step by step, because the process is very similar to what you just saw a moment ago, but there's some slight differences in how it actually is done on mobile devices. Okay, so first step, you have to install the NativeScript Bluetooth plugin. That's pretty simple. And when you use the Bluetooth plugin, you obviously have to request the permissions. So when you call request calls location permission, that basically will give you a little pop-up in your phone saying like, oh, this app is trying to use Bluetooth. Are you okay with that? And if you accept it, then we can carry on. If you reject it, then, well, the Bluetooth won't work, right? Next step is we have this scanning process. So you call Bluetooth.start scanning, say for how long, and usually for each device that gets discovered, you get a little callback. So the library will not build you a UI that kind of allows you to search. It gives you the data. So if there's like 20 Bluetooth devices in the room, this callback will fire 20 times. And really what you need to display to the user is the UUID and the name. The name is for the user to recognize the device. UID is how you actually connect to the specific drone or robot. Then once we decided which UID we want to take, you have to call Bluetooth.connect. So then you pass that UID that you selected, and then you have 2 callbacks. You have one callback on connected. So it can take up to like 2-3 seconds to actually connect to the device. And when the connection is done, you get this peripheral object, or I call it device, it's easier to pronounce. And then once the connection is done, this is the moment we can start sending instructions to the drone. But also there is a second callback called onDisconnected. So whenever your device disconnected, you have to do the cleanup, right? So if let's say you were in a different screen that is used for control and you disconnected, you can navigate back to the home screen where you can scan for devices, for example. And also, why is onDisconnected returning an object is because you could be connected to 10 devices at the same time. So if one of them got disconnected, you could clean up maybe just for that one device, but still talking to all the other ones, for example. So once we connected, then we can start performing different operations. So you remember with Web Bluetooth, we created this service and characteristic object that we're communicating to. We don't have to do that with, in this case. All we have to do is, for every time we want to read something, you provide the device UID, the service UID, and the characteristic UID, and then execute read. And then this will give you like a result object, which again, you have to convert into uint8 array, which then gives you all the information that you need. So it's pretty much the same idea, the syntax is just slightly different. If you want to send an instruction, again, you construct this similar object, but this time you also pass in a value object. So this can be a string, or it can be actually an int8 array, which I usually use. And then you basically call write without response, and then pass in that object. And there's two types of writes. There's just write and write without response. I usually use this one because if you're trying to fire a new command every 50 milliseconds, write is too slow because write sends an instruction and waits for response. And that doesn't usually work very, very well if you're trying to continuously control a device. So I usually use write without response and then fire loads of commands. So a new hero arrives. I call him General MePush. It's basically, if you want to look it up, it's a company called Wowie, and this model is called MIP, like MIP. And also for simplicity, I actually created a library that you could use inside NativeScript. So you could install NativeScript MIP BLE, and by just creating a new MIP device where you pass in the UID name and status, you could then call things like mip.move or turn left or talk. There's like all sort of functionality that I incorporated in there. So I think it's time for me to show you how MePush works and how actually we will build an application to talk to him. So I have this app over here that is just the skeleton of the application. So let me hide this. So you can see, and I'm going to run a build for it. So basically, what's going on? I just need to unlock my demo phone. Try to connect. Let's see. I just really want to show you what I have on my device so that you can kind of follow. So, oops. This is my application. It's pretty basic. You have like a scan button. This is a list view that will display our devices. So we really just have to implement that. So I'm already handling permissions, etc. But what we need to do is basically scan for the devices. So if I do Bluetooth.scan, start scanning even. Actually, I'll just use a code snippet. That's easier. So I can do Bluetooth start scanning, and I can skip permission check. I will scan for 4 seconds, and then we have this event onDiscovered. That we can do something. So I can, for example, what's going on? Print the peripheral UID. Each time we get a new device. But really what I want to do, I have this devices array that's what really is populated here, that I can call this dot add device, and then I just have to pass the peripheral name and peripheral UID. You can see like there's some other pieces of information. But if I save that, let me start me push. Here we go. Pressing scan. See, it finds like all sort of devices. There's a lot of Bluetooth devices that don't even have a name. So what I can maybe do is do a quick if peripheral.name. So let's do that. Save it and quickly reload. And now scanning, you see like, yeah, we have 3. So there's somebody has Libo's free sound support. Should we connect and mess it up? Maybe not. All right, so next thing is for each button, if I click, it will call connect with the UUID of that device. So I'll use the code snippet again. So basically what we need to do is call bluetooth.connect, and I will pass in the UID that comes from the button. And then when we connect it to the device, I will just basically navigate to the controller. And then I'll pass in the UUID. So it's like this is a standard Angular navigation. I'm just navigating to a page called MeetLikeMIP controller. And then when we get disconnected, I will navigate to the scan page again, so it's this page. So let me save this. And now let's press scan, press me push, and you can see his color went green. That means that he got connected, and we can now press like move forward, back, right, left, and that should do something. Except at the moment, oh, my phone got disconnected. What's going on? That happens sometimes. So we basically have to implement those commands. Come on, SiteSync. I may have been using this cable for a little bit too long. All right, coming back. Cool. So this is my MIP controller. So whenever I press move forward, it will call this function. This is the back function, turn left and right. So let's implement this part now. So what we need to do is call Bluetooth write without response. So my peripheral UID is going to be the device UID. So when I navigate to this particular page, I'm actually getting the UID that was passed in as a parameter. So that's number one. The service UID, for this robot, I will always be using FFE5 and FFE9 for the characteristic, okay? So let me do this. This device, service UID, and this characteristic UID, and I'll go back to the device in a second. And what goes in here, we can get from the documentation from WOE. So actually, they shown like all the instructions and how you can call them. So if you want to tell it to drive forward, you just have to pass 0x71, and then second field is the speed, which is a value between 0 and 30, and then the third one is for how long you want to make it drive. So what I will do is say this. So first one 0x71. Then we say speed, well, 30, duh. And then for how long? Let's do like 200. And then to move back is pretty much similar. It's the same thing except with 0x72. So let me copy this. So 0x72. Well, going backwards is dangerous. Let's just go 20, a little bit slower. And then if you want to turn left and right, again, is 0x73. we have to provide the angle and the speed at which we should be turning. So 0x73, so angle is not exactly, because it depends on the battery levels, how much it turns. So sometimes 90 means 90, sometimes means 80 when it gets lazy. And then speed, let's say 20. So that's left. And then finally, I can do right. Let's try to connect one more time. And I should be able to demo the whole thing. All right, so scan. Ah, you didn't get disconnected. Interesting. Oh yeah, because I'm using hot module replacement, so I was actually not reloading the actual application. That's a good one. All right, connecting to MeetLikeMIP. He's blue, he's gonna be green. Yeah, and now if I put him down, hands up, me push, be proud. Come on. There you go. I can press move forward, and he moves forward. Again, turn right, turn left, go back. Go, me push, go to the nice lady and say hi. Hello. He can dance as well and stuff like that. And there's also, like, I obviously implemented accelerometer with it. So there's another one where I can send a command to it every 50 milliseconds. And then I can control him by just tilting my phone and then make him move, more precisely. So get very close, nice and close. Hello. Show your side, show your other side, like a proper catwalk. I actually organized some football, mini football tournaments and stuff with the robot, and people were pushing beach balls and stuff like that. So that was pretty cool. So yeah, that's basically what I have for MeetPush. And he also has another trick. So let me disconnect him. Let's see how we're doing on time. I got time. I haven't implemented that, but this is basically me at home. Sometimes we get bored. I have 5 of them, and they all do this. He can dance. And he has all sorts of songs. All right. Enough showing off. This is my show. Cool. So this is basically how you talk to robots, right? You make them dance and everything. And that's how you can basically hope to defeat crazy squirrels, I think he could even go against Daenerys. He would fight her. No spoilers. What do you think so far? Did you like it? No? Huh? You guys are so quiet. Maybe it's because it's 10 o'clock in the morning. All right. So this part, if you weren't amazed just yet, this part is going to be even cooler. So I want to talk about reverse engineering, because the biggest challenge of working with Bluetooth is actually knowing what commands to even send, what characteristics and services that you can use. Because I swear most of those devices that I ever played with have very poor documentation, and very often is very confusing of what is going even on in there. So with my drone, I discovered that there is this little cannon. And this cannon, if I attach it on top, well, it should be doing something, right? But the documentation that I had for the drone had nothing about it, nothing whatsoever. So what I did is said well, I have to figure out how to use it, because there's no demo without the drone that can fire bullets. And so what I did is I found the native application that was provided by the guys from Mambo, from Mambo, on how to, the original application that was provided by Mambo that you could use to control the drone, and there was a button to fire the bullet, okay? So I said, okay, so there will be a signal sent from my phone somehow, so I can intercept it, right? So in Android, if you're running Android, you can basically use Bluetooth HCI HCI snooping. So if you enable that, any Bluetooth commands that happen on your phone will basically be saved into this btsnoop HCI log file, right? So I was like, okay, we're onto somewhere. So I can go and fire the bullet a few times, and then maybe I'll be able to find the command. The thing is, like, after you open the log, it's all like, it looks like gibberish because it's just all binary. So the next step is you use this tool called Wireshark, and then Wireshark actually understands the language that is in the Snoop log, and then if you see like one of the commands, it will tell you like what service ID was used, what was the value that was passed in, etc., etc. So you can kind of go and figure out how to execute a command. So that's really cool. So what I did is this. I took my drone while it was landed. I fired twice. I made it take off and land. I fired 3 times, and I did take off and land again. So we all remembered like takeoff was like 010 with the prefix, right? So basically the idea was that, on native device actually 4 step 2, and then land was like 4 step 2 030. So basically all I had to do is just find this somewhere in the log, and then in between there should be my fire instructions. Yeah, so like ignoring the prefix, this should be my command, I should be able to see. So let me do a quick demo, because this is the Snoop log that I recorded a little while ago. So I already kind of zoomed in, but this is basically over here, my takeoff and land command, takeoff and land. So anything in between here, these are my commands for basically firing the bullet. So you have the 0, 4, 1, 1 is steps, is 11, 12, 13, 14, 15. And then there is 0, 2. And this bit here, 10, 0, 2, and a bunch of zeros, is my command to fire. Right? So I was like, yes, I am getting somewhere. So if in case you didn't follow that, I'll illustrate it again. It's basically my takeoff and land over here. I'm removing the bits for that is always the prefix, and basically this is exactly the command that I had to implement. So basically in my code, all I had to do is just add this new instruction that was write without response. That was basically 16, 2, and a bunch of zeros, right? Because this 10 is actually 0x10, right? And then with that, I could do this. So, oops, let me go out of presentation. And I'll ask for a volunteer. Anyone wants to volunteer their life for the demo? Anyone? Come on, guys. Come on, yes. There you go. What's your name? Peter. Peter, okay. Peter the volunteer. So,
It's like Matrix or...
well, if you get shot, you have to die. That's basically the idea. If you don't, my second attempt will be harder. So trust me. You can try to dodge, but I will get you. I've been practicing. So it doesn't hurt. You die instantly. That's the idea. You just die instantly. There you go. Ready to fly. Ready to die. All right. Oh, he's running. He's running. He's not going to run. Don't worry. He's not going to hurt. All right. A bit lower in the chest. Fire. Oh, die! Come on. He didn't die. What are you? All right. Hit him again. No, that's... All right. Kamikaze! Ah! Thanks a lot. No, cool. Well, usually squirrels die. Squirrels die. Oh, come here. Thanks a lot. Great acting, great acting. He was like Schwarzenegger. You shoot him and he stays alive. All right. So, going back. Fire instructions. So what was the result of the battle for the unnamed woods, or like for the park where I live? Well, it was simply unconditional surrender. Like all the squirrels are like, you got robots, you got drones, you can fire at us bullets, and even if you run out of bullets, you're gonna fly into us. They were like, okay, it's not enough, not worth the effort, right? Like, bring your people, bring your dogs, we'll be fine with that. Anyway, summary. So what I wanted to really show you that working Bluetooth is fun and it's actually quite easy. You can see a bunch of examples of libraries that I created. You can go and have a look at them at some point. And like I said, the actual commands that you execute are very, very easy. The hardest part is sometimes figuring out what is the API. But once you kind of figure out the first steps, it's pretty easy and it's really nice. You could use NativeScript basically for if you want to connect to Android and iOS, and if you want to be able to connect up to 10 devices, because natively those devices can connect to that many. You could use web Bluetooth pretty much on Chrome, on Mac, Windows, and Android as well. But a session can only have one device connected at a time, right? If you want to do like a dance party like I do at home sometimes, then you can't do it with web Bluetooth, or you'd have to have 3 or 4 tabs open for the same stuff. And you could also, like I was showing you the approach with promises, but if you use, there's an Angular Web Bluetooth library as well that uses observables done by Wasim or Manakineko, that's his hashtag. So if you want to use observables, that's a very good library to use. And overall, like with reverse engineering, use HCI Snoopblock and Wireshark to figure out what's going on if you already have an existing application that you would want to play with. And you could kind of try also to use some sort of pattern matching tools. If you're trying to look for a command but you can't find it exactly, you could try kind of say like, where is my 010 somewhere? Like sometimes if you have like a million lines in there, it could be tricky to find the one you're looking for. And I was working at one point to even like create a replay tool that was using the Snoopblock that was firing things step by step. Because if you have like, a whole bunch of commands, but only one of them is the one you're looking for, you could actually fire them one by one until the one that you need comes up. But yeah, this is pretty much me. Yeah, thanks for listening and thanks for your attention.